So that was about how cell numbers publicly available can be actually used. How can you actually create risk communication to tell people that what are the risks if their cell numbers are publicly available. I'm sure you can think of other ways of actually expanding this discussion, having your own ideas on not just cell numbers. You can start thinking about passport numbers, Aadhaar number. There are many types of personally identifiable information that are getting shared on social media these days. So I'm sure you can think of ways to connect it to what you are seeing, or what you may have connected to the information that you're seeing publicly available. Anytime you see some of these kind of things, I think you should start thinking about, what solutions can you build? How can you help them? Because it may be sometimes that the people are posting it without knowledge, right, of the ramifications of it. Or some people consciously want to post, like for example, one of the tweets that I showed you, where a user is actually telling others to call the user a number and disturb her. Right? So that kind of things, I think, should be somehow found a way to delete it. Probably reporting the tweet may be one solution. Finding methods by which that can be connected to the user whose number is being posted there, and that user is actually said that your number is online, or some things like that, right? Okay, so that's what this Call Me Maybe paper is all about. So next thing that I wanted to cover is about the location-based social network. I think in my first week, you saw one slide which has mentioned about, I think, Foursquare. We were having a lot of discussions about these 4 V's, right? 4 V's of social media, and in that we talked about variety, right, velocity, volume, and veracity. Right. So, and then I also mentioned that there's 5th V that's being discussed, which is value. So keeping this in mind, there was one mention about Foursquare. I think many of you did not know about Foursquare, or may not have used Foursquare very frequently also. It's not a very popular social network in India. But Foursquare has a feature which is actually very popular in India now, which is this location-based, where you can. So why do we need location-based? Let's start from there, right? Location-based social networks are extremely useful to provide suggestions, recommendations to users, which are very, very timely, right? If I know that you are in Gachibowli now, or you are in Connaught Place now in Delhi, right? Or you are in Dadar in Mumbai. If I know those locations that you are going to be, or you are currently then I think we can produce a lot of interesting recommendations for you, right? Given that the assumption is that you're okay with getting those recommendations. Right? If that is acceptable, if that is disclaimer there, then I think this location-based works very, very well. And what kind of recommendations can be? It could be saying that, oh, look, you're in this mall in Chennai. There's an Adidas showroom and there's a 20% sale in this mall right now. Or it's around during lunchtime. Or this, if you go to this ice cream parlor and give this code, you'll get 15% discount on the bill. Right? So all of this could be very, very useful. Again, please remember, it is assuming that you as a user have accepted the condition that your information can be used to provide these advertisements. Right? It can also be useful for crime detection, right? So assuming that if I get access to all the victim, right, victim's location, where all he or she has been through this location-based social network, then I can actually profile the user and see whether I can get to some other information using that. Right? So if the victim has moved from 3 different places inside Hyderabad, can I actually go to those places, look at what, collect some information from those places and use it for crime detection? All right. So many use cases are there if the location is available. Of course, it is also privacy, which is why we are studying in this course. It is also privacy invasive. If I keep the location information not public, and still if that could be used for deriving where I am, then it's actually invasive. Or probably I allowed only the service provider to make the choice using my location, but that information is actually provided to everybody now. Right? So these kind of privacy issues are there when the location-based information is shared. Right? So this is the way I'm sure many of you would have seen the location-based social network right now. So when I was preparing for this lecture, I was trying to check into IIIT Hyderabad. So in Facebook, if you're going to create a post, if you go look for this particular 3 dots, and then it'll actually give you, if you click on the 3 dots, you'll get this location, and then from there you can say that I'm going to check into IIIT Hyderabad, and then you do a post. Now this post is connected to this location, and then if anybody looks at all the posts that are in that location, they can get this post. This is also very helpful because for example, let's take if you are traveling to another city and you want all your friends to know that you are in that city. You don't have to SMS every friend. You don't have to email. You don't have to. Basically, the way I see it is that you don't need anybody's email address or cell number anymore. If you're connected to them on social, that's good enough. That's why if you see, if any of you have been following me on social networks throughout this class, you would have seen me posting about the places I've traveled. When I travel, I take a picture in the airport saying that, oh, I'm in the city for so many hours, or there are people around here, I can catch up. Right? I'm sure if I want, I can send it to the specific people whom I want to speak with, which I did anyways in my travel, which I do anyways. But this is more like a broadcasting of, let's take for example, an alumni in IIIT Hyderabad is there, alumni of IIIT Delhi is there. We want to catch up. I don't know the number of these people, right? I don't know the email addresses, all that. But on the other side, there's me saying that I'm not in Hyderabad, that I'm traveling to a city A can also be misused against me. For example, there used to be a service called pleaserobme.com. I think the site is still there. If you go look at pleaserobme.com, what they did was, so for example, in my profile, right? In my profile, you will see that I'm in Hyderabad now. Right? It says IIIT Hyderabad, all that, right? So they would look at my tweet where I say that, oh, I'm traveling to hashtag, let's take Jaipur. Or I could have checked into airport in Jaipur. Any of that location. Location information can be derived by 3-4 ways. One, I've written it in my profile. 2, I post the tweet in geotagged locations. 3, I'm actually saying in the post itself, oh, landed in Jaipur airport. I'm around for so many hours. Right. All of this pleaserobme.com looks at and then says that, oh, look, he's from Hyderabad. He's saying that he's in Jaipur, which means he's not in Hyderabad. So let's just post his profile on pleaserobme.com for burglars to get to my home. Right? So that's the idea of pleaserobme.com, and it was basically using the location-based information that users are sharing on social network. Right? And I'm also guessing you would have seen on Facebook, this is only a location-based post that I did. But if you were to do a post saying I'm going from Hyderabad airport to Delhi airport, then there would be an India map. There would be a red line from like this, Hyderabad to Delhi. And it will show that the post that I said saying 48 hours in Delhi, anybody around to meet. Right? So many of us would have seen, I'm sure you have seen these kind of posts on your timeline. That's what I'm talking about. Interestingly, there is a social network which is Foursquare, very, very popular. In terms of only the location base, right? Here, I mean, like the Facebook, like the Insta, the minimum atomic level information on this platform is actually a location. Whereas in YouTube, it's a video. In Twitter, it's a microblog text. Facebook, it could be images, it could be text, all that. Right? Foursquare is an interesting social network in that sense because so just look at this part of the image. So these are the check-ins of the user, right? In some part of the world. It's easy to derive which part of the world. It's New York. So the way it works is that you go, you are traveling, you take your phone, you kind of go to the Foursquare app and you say that, oh, I want to actually check into this location, for example, which is exactly what I was doing in IIIT Hyderabad, this slide. Right? I'm doing a post saying that post is either relevant to IIIT Hyderabad, I am in IIIT Hyderabad, all that. Similarly, I could actually check into IIIT Hyderabad on Foursquare. Right? So that's this blue marker. So these are the locations that the user. So if you notice, there are two different colors here. There's one orange here and another orange here. Before going ahead with the video, can you pause and think for a second? What would that be? Hopefully you thought about it and you had some answers. But these orange ones are interesting information that it's basically called as mayorship. Mayorship is a concept that Foursquare had, which is if you are the person that has come to that location and checked in the most number of times in the last 60 days, then you become the mayor of that location. Why is that useful? This is useful in many ways. Again, I think all of these social networks, the features that they had some kind of motivation, incentive for users to use, and that's why they are getting popular. So the mayorship is actually very useful, is because if I know that you are the mayor in this location, for example, think of a restaurant, right? I run a restaurant and you are the mayor and you come to my hotel for food, and I know that you are inside the restaurant right now. Very useful, right? Because I can actually come and talk to you. Thank you for coming more frequently. I can give you 10-15% discount. I can find my chef to come and talk to you. I mean, I think all of this is happening, by the way. I'm not making it up. All of this, meaning I have seen it myself to go to restaurants, and there's a screen that is projected where they project all the Foursquare users who have checked into the restaurant right now and who are in the restaurant, and the mayor would show up on the top. Right? There can be only one mayor because number of times somebody could be maximum. I don't know what they do when two people are the same number, but in last 60 days, same number, probably the probability is very low. So therefore, this mayorship is very useful. Mayorship also gives you a lot of information about the person's preference, right? I come to the restaurant and I'm in the last 60 days. I mean, also please remember, it could be that in the last 60 days, nobody has checked into that restaurant and I'm the first person to check in and I become the mayor. That's also true. But if it's a popular place and if there are more people checking in, then if you're a mayor, it just gives you more that mayor feeling, I guess, right? This mayorship has been also used for sort of say giving parking spot free. For example, malls in some locations actually provide, if you're a mayor, you get a 1 week parking free. Right? So monetization of some of these things has happened very well, or is happening very well, using these social networks. So the mayorship also can give you a lot more. I mean, this is about restaurant and all that, right? But think about mayorship, how we could actually use the mayorship, right? For example, if you're at home, if you're checking in at home or if you're checking in at your work, potentially we could find out that if you are going to that location more and more frequently, it could be something that you're interested in, right? Let's take a place that you go jog every day, it looks like, right? There is also another network called Strava, which has this, which is designed for doing it for exercise, jogging, and cycling, all that. But if you were to say Lodi Garden, if you go in Delhi for walking every day and you check in, so we know that's something you do that in that location very frequently. Okay, that's the details about what a location-based social network is. What we'll do now is we'll actually look at the flip side, right? That's the basics of social location-based social network. Now I'll flip around and then see how we can use the same information to actually find something that you're not making public, right? Two parts of this work. One, I will go in very detail. The other one, I will let you actually look at it yourself. Skim it through, but I will actually let you to look at it yourself more closely. The first one is, we know where you live, privacy concerns of Foursquare behavior. The second one is, beware of what you share, inferring home locations in social networks. Both ideas are the same. These ideas are also built on some concepts like, so there are others who have studied, if you upload a picture on social network, right, without saying what location it is, still the location can be inferred, roughly, right? You take a picture in front of a Eiffel Tower, you take a picture of you standing in front of let's take Taj Mahal. What is difficulty in figuring out what location it is, right? Yeah, but if you do it in front of IIIT Hyderabad, when the buildings are not known or the location is everything is trees, it's hard to find, right? So that's the sort of say spectrum. Or inside your home, you take a picture and upload it. How do we find out where this location is, right? Outdoor pictures, I think it's possibly easier to get which locations are, particularly when they are popular, when there are more and more pictures around these locations, it's probably easier to find out which location this is, right? But we'll actually use the location-based information to derive where you live and where you work, okay? So let's go to the paper. So that's the paper. And in the process of this, I'm also letting you to look at paper, because if you remember the post condition for the course, one of it is to actually to look at papers and understand how to review a paper, how to understand what is in the paper, all that. So this is Foursquare. Right? It's using Foursquare as the network. Before we get into the details of the paper, we need to know some specific technical terms, which is part of Foursquare. I just used the check-in word very casually. Check-in is a mechanism in which in Foursquare you say that I'm in this location now. So here check-ins are there. So unlike check-ins, which are shared only with friends, the list of mayorships, tips, and duns of a user are publicly available to everyone, thus raising concerns about disclosure of the user's movements, patterns, and interests. Right? So we'll see. Don't worry. We'll see what a tip is, what a dun is. We know what this is. We know what this is. Right? So the goal of the paper was to characterize the use of a mayorship's tips and duns in Foursquare based on a data set of 13 million users. At that point in time, whenever this work was done, 13 million users of Foursquare was the largest data that was used. It's potentially, arguably, the entire Foursquare at that point in time. So the results were 78% of the users within 50 kilometers could be derived, which is I could actually accurately find out that where your home location is with an error rate of 50 kilometers, 78% of the times. Right. So I don't know whether that's intrusive enough, but think about it, right? If I can easily find out 50 kilometers is a little long, but when you see the graph, you'll actually see that this 50 kilometers is only the max to look at one set of users. But there are users who you can easily find out where their home is, where they work, probably 0 kilometers point in time. Okay. Again, I'm going to look at only the specific parts of the paper just to give you the insights on important parts of the paper and to get a sense of what the analysis is. Feel free to read the paper if you're interested. If you have any questions, please post it. I'll be happy to actually answer. This is one of the super cool work we did. Meaning, I think all the work that we're discussing in this course are actually cool work that we had done at some point in time. But this is definitely one of the interesting pieces of work that we did. So what is a tip? Now, right? Users can post tips at specific venues, commenting on their previous experience when visiting the corresponding physical places. So I come to IIIT Hyderabad, I see that I've already checked into the location and I want to give a tip saying that, oh, the campus is very beautiful, right? The buildings are very new, the classrooms are very modern, right? So these kind of inputs, if you give, those are the tips. What is a venue? Venue is a IIIT Hyderabad itself is a venue. Taj Mahal, Eiffel Tower, Connaught Place. These are venues on Foursquare. When visiting a venue page, after reading a previously posted tip, which is I posted saying that IIIT Hyderabad is a beautiful campus, a user may mark it as a done or a to-do in sign of agreement with the tip content or intention to visit that location in a future respective. So now we are defining what a tip or what a done or a to-do is, which is I posted IIIT Hyderabad is a beautiful campus. You come and see it. You also agree to it, saying, yeah, I also agree to it. Or you've never been to IIIT Hyderabad campus and you say that, look, I want to go to this campus. Right? So both is what is it done, which is you agree to do, is you want to actually do. You want to actually visit campus. I don't know, but it may be the case that you can think about it for let's take a restaurant, right? I ate in a restaurant and then I like the restaurant, and I say that the restaurant is pretty good, the menu is very good, they have a diverse set of menu, the food was very high quality, the hygiene was good, all that I say, and then you can actually done or to do with it. So this was entire data of Foursquare at some point in time. So this is the 13.5 million users that was mentioned earlier. A dataset contained 10 million tips, 9 million dons, 15 million mayorships, and 15 million venues. Huge data, actually. And that's the fun part about studying social networks also. Everything is huge. Okay. I'll give you a sense of the magnitude of the data, right? Any conclusions you're making from this, it may be very, very appropriate. You should also look up. So if any of you are interested in just this large and everything, you should also look up a course that I'm teaching on campus this semester called the syllabus is online, computational social science. There we actually discuss, do you really need such large data to make large inferences? And is it appropriate even to keep collecting more and more data to answer the same kind of questions? Right? But that's for a different course, different goal there. Okay. With these data, tips, dons, check-ins, all that is available, what can we do, right? What else can we create? So we created a dictionary of city names using the Yahoo Place Finder, and use the Yahoo geocoding API to go ask for a location given. You checked into, let's take Connaught Place or Sarana Bhavan in Connaught Place. You give this information, Sarana Bhavan, Connaught Place, back to Yahoo Place Finder, and then it will return a location saying it's Connaught Place, or it will return a location saying this is the lat long, which is what is written later. Place Finder returns that the query quality is at the granularity of the city and provides the corresponding geographic coordinates, right? A standardized city name as well as the state and the country names. Yahoo Place Finder may also identify locations at the finer granularity of streets. Moreover, note that the use of standardized city names allows us to uniquely identify the city despite the existence of multiple name variations. Unfortunately, in India, it may be much harder to achieve this because, for example, triple ID Delhi address is triple IT Delhi near Govindpuri metro station, right? Okla phase 3 Delhi, blah blah blah. So now this part, how do you actually decipher? How do you disambiguate? Very hard, right? So if the addresses are much more cleaner, it's easy to actually triangulate, find the lat long, right? I'm just posing a sort of a technical challenge here in terms of finding the location given the address. Particularly in India, it's very hard to get the address given the constraint that I just now mentioned. Let's look at some analysis, right? Figure 1, so that is this. So this is figure 1. This is figure 2. So this is showing the cumulative distribution of number of mayorships, tips and dons per user, cumulative distribution of number of mayorships, tips and dons per city. So essentially the goal, why do we have to draw this graph, right? These graphs are necessary in terms of saying what is the pattern of the data that you have collected. Particularly in this one, it's like this power law. It's like this large number of check-ins are created by small number of people. And this behavior is consistent across many social networks. Facebook, many people do less of posts, but a small set of proportion people do a large chunk of post. Power law, Pareto principle, there are many names for this behavior. And drawing this graph and having a confirmation that this is how the data is very, very useful. Okay. That's what this data says. Shown and for consistent with previous analysis of Foursquare, the distribution of the numbers of mayors, tips, and duns per user are very skewed with a heavy tail, implying that few users have many mayorships, tips, and duns, while the vast majority have only one mayorship, tip, or dun. Indeed, for users that have one of these attributes, we find that 69% of users have two or more mayorships, tips, and duns. Right. So that's very small, right? The same thing for figure 2. This is figure 2. This is per city. Figure 2, the distribution of the number of mayors and tips and duns per city, considering only cities with at least one instant of the attribute, which is your check-ins, tips, and duns mayors are available. As shown in the distributions, are also very skewed, with a few cities having many as 100 mayorships, tips, or duns. Right. So this is the power law behavior. Any analysis that you do in social, it's good to, there's also arguments that you will see online about, is this even a power law behavior? Is it even necessary? The social network power law behavior itself is wrong, all that. But having a verification of what kind of pattern distribution your data is very useful. So for instance, mayorships are more concentrated. So now this is looking at where the mayorships are. I'll show you a graph, world map where this is displayed. For instance, mayorships are concentrated in Southeast Asia, in cities like Jakarta, Bandung, and Singapore, which are the top 3 cities in the number of mayorships, jointly having more than 500,000 mayorships. Just 3 cities having 500,000 mayorships, right? Tips in turn are concentrated on different locations around the earth. The top 3 cities in the number of tips are New York, Jakarta, and Sao Paulo, with a total of 600,000 tips. Duns, on the other hand, tend to be concentrated in venues in the United States in cities like New York, Chicago, and San Francisco. Together, they have a million duns. Right? Again, the same thing. Few cities having large number of duns, tips, and mayorships. Here's the world map I said. Right, so this is showing you world map. This is the mayorships. So these are all the blue dots are all the mayorships that we have data for. The darker red dots here are the ones that are for tips. Green is for the duns here. Quite so to say spread out, but concentrated on some parts of the world, which is understandable, right? You can see, even though many of us don't use Foursquare, you can see almost in all the 3 we have India. So please try out if you're interested in exploring Foursquare. Try out and let us know what do you find. How do you find using it? Yeah. So as the map shows, same world map, Foursquare venues are spread all over the world, including remote places such as Svalbard and archipelago in the Arctic Ocean with coordinates. When doing this, it's interesting. No, you'll find some locations. Look at all this, right? Look at these kind of locations. I don't know whether there's any land also in these places, right? Which was interesting, but that's we are just pointing it out here. 50% of the users have an average interactivity time. So this is now looking at the graph of 4 and 5. 4 is cumulative distribution of time interval between consecutive tips, turns, and posted previous, which is, this is analyzing if PK does a post now, PK does a post another 1 hour later. That's what this is capturing. So this would be time difference between two different posts, right? So this would help us to know how frequently I'm actually using the platform, frequently doing an activity in the platform, to be more precise, right? And then this one is cumulative distribution of displacement between. So now I know that PK did a check-in after 3 days from the last one. How far these two locations were, two venue were. That's what this graph is showing. For instance, around 50% of the users have an average interactivity time of at least 450 hours, right? Whereas around 80% of the users have a maximum interactivity time of around 167 hours, which is roughly 178 hours is 178, something around that is number of hours, 24 into 7, right? So yeah, 168 hours per week, right? So that's roughly a week. So therefore, there is some pattern in the, maybe there is some pattern in the user checking in on Foursquare, right? So this is figure 5, the one that we saw here. This is figure 4, this one, and now what we're going to see is actually figure 5, right? So this is a figure 5 shows the distribution of these measures for all the analyzed users. Around 36% of the users have an average maximum displacement of 0 kilometers. You remember earlier I said there may be that I'm in the same location, I'm checking in the same location even after a week apart, right? So that's 0 kilometers, 36%, which means my error rate can be pretty high, pretty low, right? In terms of saying that, is this at home? Is this at office? Is this something, a place that they like? All of that, indicating very short distances within a few meters. Moreover, 70% of the users have an average distance displacement of at least 150 kilometers, which could be characterized as within a metropolitan city, of a metropolitan area of a large city. Also, 60% of the users have a maximum displacement of at most 100 kilometers, possibly the distance between neighboring cities. About 10% of the users have a maximum displacement of about 6,000 kilometers. And this could be that, look, I traveled from Delhi to Kanyakumari or Delhi to Dubai. I checked into the airport in Delhi. I checked into the airport in Dubai. So 6,000 kilometers, right? Yeah. So I hope this is giving you a sense of what the platform is and details of the platform. The curve shows clear daily patterns with returning times often multiples of 24, which is a very similar distribution of returning times computed based on check-ins. So what this graph is showing, this is talking about figure 6. I'll show you a figure 6 in a second. So the distribution of return times. So this is a very interesting graph. I kind of alluded earlier when I made that comment, I had this graph in mind. That is, you see a pattern. This pattern is happening for 24 hours. Every 24 hours, there's a spike in the location that you're checking in. Right? Every 24 hours, the check-ins of, right, for a location, not for a location, for a user, the locations that they check in is actually higher and higher every time. You can make some guesses, right? I'm going to office every day. From office, I'm coming back home. Right? I came back home today at 6 p.m. Tomorrow also roughly I'll come back around 6 p.m. I get into office at 10 a.m. today. Potentially I'll get into office 10 a.m. tomorrow. So there's a 24-hour cycle between the check-ins in that location. That's what this is highlighting. The curve shows clearly daily patterns with 24 hours of difference. 24 hours of multiples. So if you see here, that's what this is showing. 24, 48, 172, 72. So all of this. 52% of the users have an average return time of at least 168 hours, which I said earlier also, which is about a week. So there are many strategies we could have actually used to find the location, right? Exact location, right? Which is if you are looking at how many of your friends are in the same location, we could have actually derived whether this is a location of your home, office, all that. Your own check-ins for sure, right? Majority voting is what we ended up actually using. But we could actually we could actually add more information to this analysis by knowing that your friends are also from the same location. Your friends are also in the close vicinity. The same user is actually going back and forth. Probably it's you and your spouse, you and your parents, right? Things like that. Yeah. So the details of how the different types of errors, different types of inferences is made. We group users into three classes. Class 0 consists of users who have a single activity, either a mayorship or a tip or a dot. Because again, if you look at the data that we have, the data can be of per user, there could be many different pieces of information, right? Mayorship, tip, dance. So we can't put all of them together. So at least one data, if for a user is there, he or she goes into class 0. In this case, the unique choice is to set the user's home location equal to their activity. Class 1 consists of users who have multiple activities with a predominant location across them, right? I see one lat long coming back again and again. For these users, the inferred location matches the most often location of their activity. Class 2, in turn, consists of users with multiple activities in which there is no single location that stands out. Our current inference approach cannot be applied to class 2 users because we cannot, it's like a fuzzy, right? We can't really infer, and we were more interested in, let's just precisely get the location of the user. That's the most interesting graph you'll find in this paper, which is, actually there's one more graph, cumulative distribution of distances between inferred and the declared user's home city, right? So this is distance between what is there and what was inferred. So we found that around 46% of the distances are around 50 kilometers. So this one is the 50 kilometer graph. So yeah, so that's the 46% mark. I'm guessing you would know how to read I think we also discussed this before. Please remember how to read a CDF graphs, all that. Right, 46% is about 50 kilometers. Which is reasonable distance between neighboring cities. Thus, combining these results with the correct inferences produced by our model, we find that we can correctly infer the city around 78% of the users within 50 kilometers of distance. Right. So it's It's interesting that I mean, if the location-based information is publicly available or even available only to friends, right? It can be actually used to infer a lot of information from that. That's what the purpose of this paper was, to argue that look, in a small distance, one can argue that 50 kilometers itself is big. But I'm sure today if you get more data, so I think the 50 kilometers could also have been because the data that we had is quite diverse. Probably if you just turn this around and say, okay, let's just analyze this only for the US, probably this distance may have been much lesser, I guess, because why I'm making that inference is if you look at the mayorship here, it's like crowded, no? Lots of data is there. So if you use only US to do the analysis, probably the distance may have been much lesser. If any of you are interested in it, you should try. Okay. So that's what this paper is. The idea of this paper was to show that we can actually infer where you live just by taking this publicly available information. The follow-up paper, which I'm not going to discuss in detail, but I'll let actually you to read and come back if you need any help in understanding the paper. Is this beware of what you share, inferring home locations and social. Very similar strategy, very similar networks. Foursquare was used here, but Foursquare, Google Plus, and Twitter, all the three networks was used in this study. Again, one graph which will infer is this one. The last graph that I showed you in the last paper is exactly this, right? Difference between real and predicted, inferred, and the real was what was used there. So in Foursquare, there's a high chance of actually getting your location more precisely, particularly because of its location-based itself, right? All right, so that's what location-based networks can be used for. So the one conclusion here was we also apply the fine-grained inference and reveals that geographic coordinates of residents of a selected group of users in our data set, approximately 60% of the users within a radius of 6 kilometers, right? 60% within 6 kilometers, which I think you can go back to this graph again. So 6 kilometers, if you're about to draw here, it'll be here. So that's what is for location-based social network, particularly privacy connected to it. That's the other paper. That's the end of week 10. Thank you for again listening to this lecture. Hopefully you're enjoying the class. Please reach out if you need any help in terms of understanding the content. The exams are also coming closer, so if you need any specific sessions or something from me, let me know. Doubt clearing sessions, I'll be happy to actually set them up, and we can actually interact. Yeah, take care. Good luck.